Hello everyone, welcome to today's Novedge webinar, Architecture Modeling in Rhino with VisualARQ and Grasshopper. Learn the great advantages of using VisualARQ and its connection with Grasshopper when working on architectural projects in Rhino. Besides VisualARQ's flexible BIM technology, you will also see how to work with VisualARQ inside Revit using the Rhino Inside new technology. Our presenter today is Francesc Salla. He is the product manager of VisualARQ and Lens Design, software plugins for BIM and landscape design for Rhino 3D. And those plugins are developed both by Asuni in Barcelona. Francesc is also an architect. Now let me tell you a little bit about Novedge. Novedge is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, faster service with zero headache. Check us out at novedge.com where you can find both VisualARQ and Lens Design, and not to mention Rhino. And now without further ado, I'm going to share Francesc's screen.
Okay, thank you very much, Barbara.
Perfect.
Thank you one more time to give me the opportunity to present you VisualARQ. Okay, today I'm going to show an overview of the program. So we'll start with a slide presentation, and later on we will see a live demo of the main features. Okay, so I hope you enjoy it. I'm gonna start with this presentation to show a little bit what means these flexible BIM features that VisualARQ adds to Rhino. Okay, so first of all, what is VisualARQ for? Basically, VisualARQ provides the option to produce BIM models inside Rhino. Okay, it provides tools to generate 2D drawings from any 3D model, and finally, it lets you exchange Rhino models through IFC with other programs in the IFC industry. All right. So basically, when we talk about BIM, we talk about managing all the data from a 3D model. Okay, that means geometry with data. That thanks to this, we can produce drawings or quantity takeoffs that are linked with the 3D model. On the other hand, VisualARQ provides a set of architectural objects that they are parametric. That means that we can change easily their dimensions or their features through parameters very quickly, and we can edit them through control points, as we can see here. And also they have a 3D representation and a plan view representation. That means that we can either work on the 3D or in plan views. Okay. So also, as I was mentioning, VisualARQ provides the option to export or import IFC files. That means that, for example, on this left hand, you've got a model created with VisualARQ objects, with walls, windows, beams, columns. And after we export that model to IFC, we can recognize these architectural objects as the objects type they are in our programs. In some cases, the parametrics of these objects are maintained. For example, a wall in VisualARQ would be a wall, true wall in Revit or in ArchiCAD. In other cases, all the parametrics will be lost, but at least we will see that these objects are the object type they are, and all the data that stores the geometry will be recognized in those programs. Okay. But when we talk about flexible BIM, we are based on the fact that VisualARQ is working on top of Rhino, which is very capable to work with organic shapes, with freeform geometry, and we can also use this freeform geometry in our BIM models. Okay, so we can get informed objects out of any freeform shape. So basically, we can take any object like this pole surface, and we can tag it as a slab. So there is a function that lets you tag an object according to an IFC category, in this case a slab. And after we export that to IFC, we will recognize this object as a floor, for example, in Revit, or as a slab in ArchiCAD. Okay. And in addition to that, we can add like custom data to the geometry. Okay. We can create new parameters, manufacturer, cost, material, whatever, and we can feed geometry with these with values for these custom parameters. Okay. and all them will be stored into the geometry and will be exported as IFC properties. Okay, and we also talk about flexible because VisualARQ integrates into Grasshopper. So you can generate all the visual objects inside Grasshopper definitions. Okay, all the objects are available there. All the data can be managed from Grasshopper components, and you can integrate that into your Grasshopper workflow. Okay, that means that we can connect the VisualARQ components with other add-ons in Grasshopper for many purposes and automating tasks. All right. So this is just a basic scheme of how the VisualARQ components work. So in the center, you can see a wall component, and if you look at the left, you can see a wall component that requires a path curve. Also, it has an option component to assign more details, such as the height, well, the style. We can create newer styles in Grasshopper. And on the right hand, we've got the components to deconstruct VisualARQ objects. So we can reference a wall and we can obtain its path curve. We can deconstruct its option to obtain the height, the information of the style, the height, etc. Okay. Styles in VisualARQ are what define the object features. Okay. For example, in case of a wall style defines the number of layers a wall has, the thickness of each layer, the attributes, the material, and all these details. Okay. So here you've got an example of a parametric tower that is created out of VisualARQ slabs and columns. Of course, we would have the similar result using extrusions, but the idea is that when we bake these components, we get true slabs and columns in Rhino. And the other way VisualARQ integrates with Grasshopper is by generating visual objects from Grasshopper definition. And this is a very powerful tool because we can have out of one Grasshopper definition, unlimited objects. Okay, so basically, this video explains a little bit how it works. Okay, so on one hand, we've got a list of parameters. So this is just a pure Grasshopper definition, and we've got a list of inputs that define the shape of this revolving door. Okay, I decided how I want this door be in terms of parameters. And at the end, the right side of this definition, we can see different geometry params that have been named with a specific name to be identified by VisualARQ, because later on we can use this definition to generate a new revolving door. Okay, I will explain that in another example during the live demo. But behind this connection of VisualARQ and Grasshopper, there is an unlimited possibilities to create your own custom objects out of Grasshopper definitions, and other people can use them also in their projects. So here I define how I want to edit these parameters in that object style. And finally, this comes here as a new door that can be inserted into the model. Grasshopper is running in the background at this point, even though we don't see it, and we can edit that door as any other door in VisualARQ. Okay? We don't really know which one has been created as a system door or is being generated by Grasshopper. Okay? So any people who even don't know Grasshopper can use objects driven by Grasshopper definition. And here we can see an example of one Grasshopper definition, use it in one style, and we can have unlimited possibilities with the same object with different dimensions. Okay. Actually, in Food for Rhino, there is a section where people are uploading their own styles generated with Grasshopper. So, of course, I encourage you to upload yours if you want to share them with the community. Okay, they are totally free. Now I would like to highlight some of the main VisualARQ features. This is the level manager that lets you work at different elevations in Rhino, and also lets you show and hide levels very, very quickly. And we can switch to a plan view representation when we're working on top view, switch between levels very, very easily. And it's a kind of navigation tool that makes the modeling process very, very handy. And it doesn't matter if you work with Rhino geometry or visual objects, because this section, this level manager works with any geometry, any project. In a similar way, there is a section panel, okay, the section manager that lets you handle a list of section lines that unlike clipping planes, as the example you see here, they can be juggled. All right, so we can switch from one section to another, and also align section view to a specific viewport. So we can have this ready to work on that view, or have this for printing. And actually, in terms of printing, VisualARQ adds the hidden display mode. That is a new display mode that lets you print what you see directly to vector output. So in this example, we've got any kind of geometry, like the Rhino logo. And as you may know, when we are using shaded views, we can only, if we choose the vector output, we will see all the edges and wires behind the surface. All right, so we can only choose the raster if we want to see hidden surfaces. But if we choose this hidden display mode, we can print directly to vector output what we see in the scene. This could be a section, this could be a 3D view, whatever. Okay. So we take this example to architectural projects. It's just a matter that you take your project, okay, you show the level you wish, right? You put in top view and you switch to this hidden display mode. So this is ready to be printed to vector output from the pitch layout. And in the same way, you can take a section, you switch to a hidden display mode, put it using the pitch layout, and that's ready to be printed. Okay, you can just get on the 3D model, but you will have all the 2D drawings ready. And as Barbara was mentioning, since VisualARQ 2.9 version, which is already available, there is the connection of VisualARQ with Revit through the Rhino technology. Right, so in this video, you can see how it works, even though you will see that there's some icons are a bit old, but VisualARQ 2.9 already works on Rhino 7, and you can already play with that feature. So as you may know, Rhino Insight is a technology that lets you run Rhino as a plugin of other programs, in this case, Revit. So I've launched, in this case, Rhino inside Revit, and I can also launch Grasshopper in that Rhino session. And here, what I do is open a file that is created, has different walls. Okay. Actually, here I'm gonna prove that these are walls and not other objects. It's connecting them in a panel. So with the VisualARQ pipeline, we can reference all walls or all VisualARQ objects at once. And here we've got a Revit component that generates a wall in Revit. Okay, so just by deconstructing the information of the wall, so we can obtain the path curve, we can connect that to the curve input in the Revit wall component and have all the walls live in Revit. Okay. If we want to change more details, for example, we can also paint the head of the VisualARQ walls and connect them to the head of the Revit walls. And once you have done this connection, you can just hide Grasshopper. And since we're using a VisualARQ pipeline, everything that we modify here or we create will show up in Revit in real time. Okay, for example, here I'm stretching a wall. You can see how the same wall stretches in Revit. Or if we add here a new wall, okay, so you will see as this piece of wall appears in Revit. And just take into account that these are true Revit walls. Okay, we select them. Now here in Revit, you will see that they are true Revit walls, so we can keep on working with them. All right, so I would like to also show some of the projects that people are using VisualARQ. So projects created with VisualARQ and how they use. And I have divided them into 3 different groups according to how they use VisualARQ. And in the first group, I would say, I would mention the people that use VisualARQ for rising 3D models using the VisualARQ objects. In the second group, they are meant to be the people that use all the documentation tools, not necessarily working with models that they have VisualARQ objects, but just Rhino geometry, but they use VisualARQ to produce all the 2D drawings. And finally, in the third group, I would put the people that use VisualARQ only for the IFC in and out capabilities. Okay. For example, in this case, there is this studio that generates this basilica, which, by the way, it's already constructed. in Solid Croatia, and they use VisualARQ for modeling the whole project in 3D, get all the floor plans, sections very quickly, and have a 3D model, a BIM model very quickly. Also, in the same group, people use VisualARQ for visualization, so they can quickly create 3D models, assign materials, and show nice renders. And also, we're seeing people using VisualARQ in scan to BIM projects, like in DCIs that they need to deliver a BIM model out of a scan, a 3D scan, with this lighthouse that was imported into Rhino through Point Cloud. And they use VisualARQ to remodel everything using VisualARQ objects. Okay, and also they had all the 2D drawings immediately done. And now this regards the second group. Again, people that maybe they model without using VisualARQ objects, just Rhino polysurfaces or surfaces, but then they use VisualARQ to generate all the 2D drawings, elevations, quantitative counts, because they can assign data to Rhino geometry as well and document it. And also with different project scales, like this mailbox design, that where VisualARQ was used to generate also all these elevations and sections. Okay. And finally, people use VisualARQ to enrich IFC files, so they can import an IFC model from the architect, from the contractor. They can add geometry. They can modify geometry in Rhino. They can edit data on the geometry. Okay, and finally send the model back to IFC thanks of VisualARQ. So, all right, before the question and answer, now we will see a live demo of what we have seen in that presentation. So just keep the questions for the end, all right? And well, basically, I will just show what we have seen in the presentation, okay, but maybe a little bit more in detail. And first of all, we can see here the main VisualARQ tools. So we've got here all the VisualARQ objects, okay, and some options available for each one of them. Okay, so basically we can create them from curves, from solids in case of walls. So this depends on every object. And here we've got the 2D documentation tools and some additional tools. Right, I'm gonna put this up here. And the first thing we're gonna see is the level manager, which I already have open here. And we have seen already how it works, but just to check it again in this last demo. In this project, we've got 3 levels. And basically from here, we can very quickly change the position of the construction plane, okay, that is located in that elevation. That means that if I draw anything now, this will be generated in that first floor elevation. But if I switch to the ground floor, now everything will be created on that level. Okay. It makes it easier, very easy to switch from one elevation to another. Also, we can hide levels. Okay, just imagine that we have a clipping plane at the position of this construction plane, okay, of the level elevation, and hide everything that is above. So we can just hide levels very easily from here and work on the inside of the project very easily. Also, levels have a cut plane. So in case of the ground floor, if I activate it, this cut plane is located at this elevation in relation to the levels elevation, and it's usually the elevation that cuts through all the doors and windows. Okay, and when we activate that cut plane in top views, so let's do the same now from that top view. I mean, I can just hide the upper level. We just see the projection of the doors here. But if I activate the cut plane, now what we see would be a plan view representation of the model. Okay, as you can see. So this is the 2D view. We can work from here. Okay, we can modify objects very easily from here, as we were working in 2D, but they are basically the 3D model. Okay. So with this button, I can put this back to top viewport. And as a tip here, we have this icon that we can display the plan view of other levels that are in other positions projected on the current level. This is very useful because we can see that plan view as a great 3D representation, so we cannot select that, but we can snap on that, so we can maybe know the position of walls that we have in other levels or hidden levels, and make sure that they are aligned properly with what we construct here. Okay, so we can even project more than one level on that current floor. All right, so let's watch this in 3D again. So in a similar way, we've got the section manager. So here we can create new section lines, and from here we can just switch from one section to another. Okay. And of course, they are related to the position of this section line. Just take into account that these section lines have an area, so they will only show what is inside the boundaries of this area. So whatever we draw in here. Okay, for example, if we draw this kind of cone, so only what is inside its limits will show up in that view. By the way, as you maybe have appreciated, we can see here some section attributes on the geometry, also in plan views. And well, in case of VisualARQ objects, I will explain that later. These section attributes are managed by the styles, even though they can also manage by object, by instance. But in case of Rhino geometry, they can only be assigned by instance. And this can be done from the properties section attributes. Okay, for example, we can take this cone, and we can, from here, we can assign a section pattern. Okay, and we can change the angle. We can assign some line weight for the contour, for the section contour. We can add a fill here, so we can define how we want to see that object in section. And for that reason, I was mentioning that people just work with models created out of Rhino geometry, pure Rhino geometry, and they just assign section attributes to them to have some section or boundaries. All right, so okay, I'm gonna switch that off. By the way, unlike clipping planes, I was mentioning that sections can be shared. So when we create a new section from here, we need to select the section style. We can just draw the section line as we were drawing a polyline. Okay, and when we are done, we define the section view, okay, the view position, and the depth of it. I'm gonna call this section S3. And now this new section appears, so we can show it. We can activate it. Okay. If we activate the control points of this section, we can even have more complex section. Okay, I'm gonna select this grip point. I'm gonna pull this so the section goes even a little bit more complicated. Okay. All right, so I'm gonna switch it off, and now we can start. Seeing how to work with VisualARQ objects. Okay, so I'm gonna just draw some wall to show you how it works. Of course, I won't have time to show all details, all the possibilities of VisualARQ objects. You will need to explore that. But the workflow to work with all of them is the same. Once you learn how to use one, you learn how to use the rest of them. For example, imagine here we want to create a wall. I've got already a few created, but I'm gonna show a new one. Okay, so I run the wall command. There is this insert dialog where I need to pick style. Okay, remember that wall styles define the features of walls, number of layers, the thickness of each layer, and so on. But here I'm gonna just choose one of these styles. Here we can define the height, alignment, and other details. Okay, so just need to draw the wall here. As you can see, the connection with the other walls is already calculated. Okay, and I can just stretch this wall through control points. Okay, or move it in our position. If I had some curved wall, if I wanted to draw some curved wall, in that case I should draw the curve first. So imagine a curve like that, and here we need to run this wall from curves. Again, select some of the insert options and finally select them. And now in this case, the control points of this wall are basically the same control points as the original curve, which still remains here, but it's not really linked to that wall anymore. So if we want to insert doors or windows here, the process is the same. So we run the door command, we get a list of door styles. Okay, I'm gonna select, for example, this one. And here we define the features of this door. There are some defined profiles, or we can just choose other, to select any other dimension. All right, so we can define even how the aperture works, maybe 50%. And in this case, the door will recognize the path of the wall and will align into it. Okay. If we move it, okay, the door will orient to the corresponding position. But if we place it outside of the, not close enough to the wall path, it will just remain floating in the model space. As soon as it identifies a wall, it snaps into it and generates the open. Okay. All right, so let's take a look now at how to produce more styles. Okay, how to manage the styles in a drawing. By the way, the usual workflow to start from scratch would be by creating new, just starting from a 2D sketch or from a 2D drawing, from a picture. And we could just work on top of this picture or change turn all these curves into visual objects in the way I have shown. All right. Okay. So let's take a look at the way to create new styles. For example, here, if I do right click, I will open the styles dialog of wall object, where we can see the existing styles. And here we expand any of these styles, we can see the number of layers. Selecting them, we can change its features. Okay, so we can assign material, we can assign the section attributes. Okay, in this case, of course, it will change all the style, or we can edit other details like the thickness, construction. Okay, for example, the construction details determine the way walls will intersect each other. A wall can be a normal or core type. For example, if we take this structural layer and we tell it it's a core, you will see that the other normal walls, normal layers wrap around it, and this layer will tend to intersect with other core layers of other wall styles, okay, in wall connections. So that's a way to also control the way the walls connect. And here, of course, we can create new styles. So we can even we can duplicate an existing one or create a new from scratch. There is this simple wizard that we can just follow, for example, to create a 3-layer count. Okay, I'm gonna say the first layer is 3 centimeters. The middle one is 14, and the other is also 3. So this wall appears now in our list of styles, and now we can pick any of each one and change, for example, the section attributes. So we can assign for this one a section pattern, and in the construction we can tell this is a core. Okay. So basically, you can build your own library of objects. They can be exchanged to be used in other documents. If you just go to VisualARQ, you go to styles, and you can export them. Okay, later on you will need to import them. And if you start a new project from a VisualARQ template, you will already see a library of existing styles. Okay. So you don't need to start from scratch. Let's take a look at how this new wall appears in plan view. So I'm going to select that wall, and now we just can change it for the new style that we have created. Okay. This works in the same way for other objects. But let's take a look at the door styles, because in case of doors, windows, actually columns as well, the options available for generating different designs are kind of limited. If we take a look at the level of details of these doors or windows, it's very simple. Okay, so there is the option to generate these door or window styles using 3D blocks or plan or 3D blocks that replace their 3D and plan view representations respectively. Okay, let's take a look at the door styles dialog. In case of this hinge style, here we can switch from plan view to 3D view. We've got a frame. Okay, we can change the features of this frame. We have a leaf. We can add maybe a glass into that leaf. Okay, there are a few options available to change the design, but of course the options are limited, and that's why it's possible to create this object using a block. But of course, a block is not parametric, so we wouldn't be able to change the dimensions of that door parametrically, but editing the original block. And the good point is that you can have like a very detailed block in the plan view and a very simple in the 3D view. But the point here is that, as I was showing in the presentation, we can also create doors from Grasshopper definitions. And we'll see how this works now. I'm going to cancel this. And I'm going to show a Grasshopper definition that generates a default door. Okay. So, so here it is. I'm going to just move this down a little bit aside. And well, this is the geometry that generates this Grasshopper definition. So just forget about the mess in the middle. Just take into account that this is just pure Grasshopper definition. So we've got some parameters that define the width of the door, the head, some other parameters for the frame, okay, for the opening. So I basically have full control of all the features that I want to edit for that door. All right. So I can change the number of leaves if I wish, or change the leaf. So the idea is that we've got this list of inputs. Okay, it's important to give a proper name, by the way, so later on you can identify them. And as outputs, we've got geometry panels that are not further connected to anything, and they need to be geometry panels. If we don't have this connected, okay, I mean if we have this floating without any connection, this component won't be recognized by VisualARQ. So we need to connect this to a geometry panel, name it accordingly, and don't have this further connect. So I have this geometry panel to collect the geometry of the frame. This is a component that collects the profile, and I will use this to determine what's the opening profile of that door into a wall. Okay. And I've got two more components for the leaves and for the glass. Okay. All right, let's save this definition now. Let's go back to the door styles dialog. And now I'm going to create a new style. So just notice that we've got here the regular door style, but here we can choose the Grasshopper option. So I will just select that default door. And when we follow the steps of this wizard, first of all, we need to determine the name of the style, definition units, and here we can select that component that performs as the opening profile. The auto option here would work already because it calculates the profile according to the bounding box of the geometry. And but since we have it, I'm going to choose it for this case. We can see here the rest of components. So we could decide whether we want to, for example, import that arrow 2D or not. And we could also assign some of these components to a plan view representation. That means that we could have in Grasshopper the 2D representation of the door parametrically created and assign it here as the plan view representation of the door. And finally, we get the list of all the sliders, all the inputs, okay, and we need to define how we want to edit them in the object, either by style, that means that all doors will have the same value, by object, so we will be able to edit this parameter by object individually, or by definition, that means that we won't be able to see that parameter in VisualARQ dialogs anymore. So in case of the aperture, for example, is something that we want to edit by object, and also we can change the type here and set it as a percentage. And we'll do the same with the width, number of leaves, and height. Okay, I'm gonna change that and leave it editable by object. And once I finish it, this is just another door in my list of door styles. The advantage of managing this in different components that we can take one, for example, the glass, and here assign specific materials. So we can assign a glass material. All right. We can assign different section attributes and so on, or put them even in layers to control the attributes by layer. And now, all right, let's insert that door. I'm gonna delete this one. Okay, I'm gonna work in the first floor, and now we can just insert the door. All right, search for it in the list of doors, and well, here you need to define the width, something that we can measure from here if you want, and yeah, just insert the door wherever you prefer. Okay, we can have even 2 copies of the door. All right, I'm gonna copy it from this point to that point. Oops, I think I didn't copy it in the right place. And now we can change the features of any of these doors individually. For example, we can actually even change the opening side through this control point. Okay, and for this one, I'm gonna change maybe the number of leaves. I will set it to 4, and also the aperture to 90%. All right. So all visual objects can be created from Grasshopper definition, except walls and curtain walls. This is a feature planned for VisualARQ version 3, but the rest can be created from Grasshopper definition, letting you generate any kind of custom parametric object. All right, let's take a look at some of the documentation tools now. So, for example, we're going to calculate the space of that ground floor, okay, of these 2 rooms by using the space command. We just need to pick inside the point surrounded by walls, doors, or visual objects, and this calculates the area, the perimeter of it. Okay, and of course, if we change, for example, the position of these surrounding doors, walls, we can later on select that space, update it, and it will recalculate the area. Actually, any geometry can be designated as a special element. For example, we will have a curve here. So we want to remove this part of the space from the main one. We can tag this curve as an element set. We can set that curve as a special element. We select it, and this will produce that the space is recalculated without taking into account that area. If we move it to another position, we can just update this, and it will recalculate the new perimeter. Okay. Well, another interesting documentation tool, for example, is the one that lets you generate opening elevations. So we have here this command that after selecting all the elevations, all the openings, we can just define an insert point, and this will generate all the elevation of these openings at once. We can take a closer look and just notice that they also got this reference mark, which is basically a field in that object, okay, that you can change from here. And if you want to see a tag below these objects, we can, for example, do add a tag for all doors. Here there are some tools to select all objects of the same type. For example, we can select all doors. Now we can run this tag command and select one tag style. And if we take a look now at the doors in plan view, we'll see this tag here, just been under the object. By the way, this tag, if we take a look at it, has this formula where this string corresponds to the object tag field. If we change it by any other property, this is what we will see in the tag. And of course, it will update if we change the dimension of that door width. Okay. All right. Another interesting feature here is, for example, this annotation object that can be also created from Grasshopper definition. Basically, this object, this elevation mark style, has been generated with a Grasshopper definition, which reads the position of its elevation and shows you the corresponding text. Okay, if we insert now this annotation in the first floor, okay, we'll see how this indicates the other elevation. All right. So we have been talking about there is all the geometry is plenty of information. Okay, and let's see how we can list that information. We can do this with a table command. We've got some styles for different object types. Of course, you can create new styles for different object types. We can actually list everything that exists in the model: blocks, meshes, poly surfaces, anything. And I'm going to show, for example, how to all the information of openings and insert that table here. Okay, now we could export that table to Excel if you wish. Or we can actually customize these fields. If we do right click here, we'll be able to change the fields. But imagine that we want to add like a custom parameter. Okay, I was talking about the option to add custom information to visual objects. So what I'm going to do is open the document properties, and we will see that there is a section where we can add like custom parameters. Okay. Here it is. So under document properties, we have this parameter section. In this document, I already have a few custom parameters, but I can add a new one. For example, case of renovation, and assign it to a category. Basically, categories are the way of grouping these, these parameters, and a data type. I say OK. Now I can pick any piece of geometry. For example, I can take this cone, and from the properties, there is this icon here where I can fit the geometry with custom data. So this can be to phase of renovation 2, for example, while this wall is a phase of renovation 1. And actually, since we can assign the values for VisualARQ objects through styles, maybe we can pick, I don't know, any of these window styles. There is an option here, which is, if we do right click here, we will open the style dialog for the particular selection. We can go to parameters and say, okay, phase of renovation 4, whatever. Okay. But now we can customize this table style. We do right click here, and under the openings, I'm gonna do right click to create a new property field. I'm gonna call this phase of renovation as well. And I just need to select here the corresponding parameter. We'll say OK. Now we will see the values of those windows that correspond to that style that we have edited. Okay. So you can see here now how to add custom data to geometry and how to list it. All right, let's take a look now at the connection with Grasshopper. We have already seen some examples in the presentation, but let's see a little bit the workflow. Just one more thing about documentation tools. We have seen how to, let's say, produce 2D drawings, okay, from the level manager and section manager in the presentation. So when we, if we wanted to create, a section view or a plan view, we just go to the new layout, and here we would just define which level we want to show. For example, we can show the first floor, and with this icon, we will switch to a hidden display mode. We will do a zoom extends. So in this case, we should zoom in to the proper scale, select the detail, and adjust the scale. But at this point, we can just do double click and show the desired floor. And we can do the same with sections. So imagine that we want to show a section here instead. So we could pick, for example, section 2. We click on this icon, and this view would align with the section view. In this case, the length is taken by the section line length. So here we should still need to select the detail and change the scale. All right. But there is another way to produce this kind of drawings. Maybe it's more in an old-fashioned way, but it could be handy for example, exporting drawings to DWG. And I'm talking about this plan view and section view tools. So we can run this section command, select section line, for example, this one, and click here to insert that section view. Okay, this is basically a 2D block of 2D lines. These 2D lines have the 2D attributes of the 3D object they represent, and it's linked with the position of that section line. Okay, if I move this in another position, I can just update this drawing, and it will recalculate the changes or the new position of the section line. All right. So I was mentioning that this is the old-fashioned way because, of course, if you are working on a project with 50 section lines, you may not want to have 50 section views here in your model. It's better to have 50 windows details in page layouts to show the model in real time. But at least this is the option now to export that drawing to DWG. All right. Okay. Let's go back to Grasshopper as I wanted to show you. So here we can see all the visual objects to create new objects from zero. For example, we can, in case of a wall, we just need to have a wall component. Okay, in this case, it will require a path curve that we can draw here. So we can reference this curve and connect it to the wall. And well, if we want to define more details on the wall, for example, which style is using, the height of it, the alignment, we need this wall options component. Okay, I'm going to use the focals to see the names of these components. And okay, with the number slider here, we can, I'm going to set this maximum to 4 meters. We can change the height of it. All right. And if we want to, and of course, everything is linked with the original curve. Okay, so if I stretch this, it completes. And if we want to insert a door here, for example, we would just put here a door component, which requires a wall as a host. The position could be maybe a point on a curve, based on the wall path curve. All right. This could be the position of the door. And if you want to define the dimensions of the door, for example, the style that it's using, so again, we would need the door options that should be connected here. And now we can just pick one style. This is something that can be done doing right click here, or there are here components to reference door styles. We can reference door styles existing in the model. Okay, we can even reference the door style that we have created before. And we can just see this, how it looks like. Okay, the opening is not performed just for performance reasons. Okay, the openings are not calculated just to make this work fast. But as soon as we bake these objects, we will see the performance. I mean the opening. I'm gonna change the style. So here, if we wanted to change the dimensions of that profile, okay, we need to this rectangular profile. And now we can maybe use the same slider to define the width, okay, and the height. All right, and if you want to see a funny thing, you can create doors or windows from any custom profile. That means that you've got a profile in that shape. Okay, we can reference this curve and use this curve as a custom profile and use it for the door. And of course, change this to have a different shape. Now, when we make the wall and the door at the same time, what we get here are like VisualARQ wall, okay, and a door that we can further edit here in the program. All right. I'm going to show you a couple of more examples. I was showing at the beginning this domino structure. Okay. Well, here you can see a little bit how it works. This is nothing but a grid of points that I've used to put VisualARQ columns and take the grid to generate the slabs. So basically, once you have got this definition, you can control the number of rows or columns for this structural grid, and with these commands, we can determine the number of levels and have all this construction modeled very, very quickly. All right, so this is a component that collects all the geometry. After baking them, we'll get here slabs, columns, and stairs. Okay, and I want to show you one more example. I mean, I could show you hundreds of examples, of course, but maybe I'm gonna show an interesting one, which is a definition that takes, with the VisualARQ pipeline component, reads all the VisualARQ objects and all the VREPs and meshes. So I'm gonna delete this. I don't want this to be taken into account for that example. So this bounding box will shrink a little bit. So I'm gonna delete also this section view, because what this definition does is reduce the 4 elevation and 2 cross sections of this model. Basically, it generates a bounding box. It takes the edges of the bottom surface, offsets a little bit. Okay, we can have here the offset value, and also generates 2 cross sections according to the midpoints of these edges. So at the end of this definition, I use this curve to generate section lines, and then with the section view component, I can, which requires a point, an insert point, but I've got it here. I'm gonna move this. I'm gonna move these elevations a little bit away, just in case. So this is already set up, to select these components that collect both section line and section view, because remember that the section view requires a section line, and make them to have the 4 elevations and 2 sections generated very, very quickly. Okay, so this is just an example of how to automate things in Grasshopper for you for sake of speed work. Okay, here we go. And there is highlights here. We can find also components to manage data. Okay, we can read parameters of VisualARQ objects. We can assign values to them. We can update properties. So there are many different things to do with the VisualARQ Grasshopper component. And all right, finally, I would like to talk about the connection with Revit. We have already seen how to connect VisualARQ with Revit through the Rhino technology. We are going to see now how to do it through IFC. So first of all, I would like to mention that, okay, all these objects are exported as the object types they are. Okay, wall as a wall, a door as a door. But in case of this code, for example, we can specify here the category we want to export that as through this IFC tag. Then we can export that, for example, as a column, for example. Or we can take that the platform and export it as a, let's say, a slab, all right? And actually, these categories can be also managed through these IFC export options. So imagine that you have all the poly surfaces in a layer that are meant to be exported as bins. So you could take the that layer and assign specific category to attack objects by layer. So all right, so exporting objects is just exporting models to IFC is as easy as select what you want to export and save it as IFC, or in this case export selected, Okay, I'm gonna call this Virasawa demo, and I'm gonna choose this IFC file format. All right. So now I'm gonna open Revit while this is safe, and let's see how Revit opens this file. So, okay, I'm gonna open IFC and choose this object. And while Revit opens this file, I mean, this may take a couple of minutes. I'm gonna show how VisualARQ opens IFC file. So we can go to File here. I'm gonna open a sample model. Okay, that is the one that Revit provides that has been exported to IFC, and now we can open it in VisualARQ and see how it reads the geometry and all the information. So if we take a look at this model, I mean, we can select everything, or we can just select here with this command all visual objects, and you can see that pretty much most of the geometry is recognized as visual objects. Okay, we've got here doors, walls, beams, columns, and furniture elements, and so on. And we can select some of these elements. For example, this window, we can see the connection with the wall still works. Okay, we can change its features. Actually, doors and windows are imported as blocks. Okay, as styles from blocks, and that's the way to recognize, to identify their objects. Of course, each program has its way to generate this geometry. And in other cases, for example, we can see that this railing is not recognized as a visual railing, but as an object tagged as an IFC railing. And if we take a look at the data stored in that geometry, we can see all the values. All right. So, okay. Let's see if Revit has opened the file already. How is it going? All right, still working on it. Just going back to this file. If you want to manage the data of this model, okay, for example, in Grasshopper, we could also read the, I don't know, maybe we can reference a wall. Okay, we could reference this wall. And here from the VisualARQ, we go to generics, we go to property names. We can read here all the parameters, all the parameters that are assigned to that wall. And with the VisualARQ get property. So this is the object. This is the list of properties. This is probably red because there are some missing data in some of these parameters, but now we can get the corresponding values, okay, to all these parameters. Okay, so we can work with this data as we wish. All right, so let's go back to Revit now. Let's hope we finally made it. Usually takes a couple of minutes, 3 minutes, depending on the object type. Or the complexity of the model. All right, here we go. I'm gonna show this in 3D. And maybe we can take a look at, for example, this cone. And now we can see that this is identified as a column. Of course, not as a true Revit column, obviously, but we still see, the custom information that we added to that object here. And if we take a look at other objects, for example, this this pattern was added as a floor, as a slab, so we can see that here. And maybe we can take a look at this, door generated with Grasshopper. Of course, this is not a parametric door anymore, But if we check its parameters, we can see that some of the parameters we had, the number of leaves, the aperture, these are parameters that are read here by okay as well. But of course, this is not a parametric door anymore in Revit, an object architecture. That's a door. All right, so this is pretty much what I wanted to show. Thank you for your time. Maybe we have some time for questions. Barbara, what do you think?
Yes, we do. Thank you so much, Francesc. So first of all, we got awesome feedback. I mean, makes me smile. But so first question, from Marco. Marco says, I bought VisualARQ some weeks ago. Will the update to VisualARQ be free, or do I have to buy an update?
Okay, the updates within the same version, now we are in version 2, are free to update. Okay, but when we release VisualARQ 3, we still don't know when will this happen. We haven't decided if what would be the price for the upgrade. I don't think it will be a free upgrade, but at least the updates within the same major version, those are for free.
And do you have a timeline for the new update for?
I don't know. I honestly don't know. We expected to have it maybe in 1 year, but everything will depend on the development, the amount of new features that we want to include, at least in the first, the first release.
Yeah, great.
We still don't know.
So everything that happens between now and, let's say, 1 year, it's all the updates are free and included.
I can't promise anything.
Okay. Question number 2: is it possible to have the 2D documentation parts, like these tables, on a separate page, or it can only be with the model area?
This is, right now it can only be inserted as a block here, but in version 3, these tables would be able to be displayed as panels. Okay, so the information of VisualARQ objects or these tables will be available from panels, and then you will decide if you want to export the information of those panels to Excel, or you want to insert them in the model or in a page layout. So this will be managed in a different way in version 3. But right now, they can only be inserted here as blocks in the model space.
And then a few people are asking if the scripts from this webinar are going to be shared anywhere, because
actually they are available already. I mean, in Food for Rhino, there is a section where people load Grasshopper definitions, and I mean, the one that generates these section views is available. Okay, just look for keyword, or maybe my username. Maybe I can just try to find them.
So great, just go Food for Rhino.
You go to Food for Rhino and under Grasshopper definitions. Here, maybe since this is mine, maybe from my profile. If you look for my profile, you will find, I mean, here you have the definition that generates the four relations to the sections. If you want the definition of the default door, I can also share it. I mean, just send me an email, okay, one of these mails, and I can share that definition with you, same as the one for the domino structure or any other one. No problem with that.
Thank you, Francesc. That's very generous of you. And the next question: is it possible to create a more modular Grasshopper component so you do not have this big mess there? So some subcomponent that then can be assembled in a more simple Grasshopper component.
Well, you know that in Grasshopper you can make clusters, and it depends on the complexity of what you want to generate. You can make clusters in Grasshopper, so you can kind of hide all this mess in a pack, in a component. And this can be used, for example, in different definitions or multiple times, in multiple places. You don't have all these, wires. So the definition doesn't look very messy, but it's just pure Grasshopper.
Thank you. Thank you. And is it possible? Is there anything on VisualARQ that allows for multiple users working in Rhino at the same time, similar to what happens in Revit and BIM 360?
Okay, yeah, if you're thinking about work sessions, unfortunately, VisualARQ doesn't support work sessions.
Okay.
But, I mean, this is something also planned in future versions.
Okay.
But what you can do is to manage files through external references. So you can have a master file and import the files that other people are working with as inserted files, but they need to be embedded and linked. Otherwise, they won't be displayed properly. And then they work as work blocks. When somebody has changed their file, you just need to come into the block manager in the master file and update those blocks to see the changes.
And is it possible to export schedules to Excel?
Yeah, it is. I mean, this is something that can be done from the context menu. Just go table, export table, or if it's easy to remember, you just go to VisualARQ, to the menu, you go to table and export. And we select the table to export, and we select here all the file. XLS, CSV. Yeah.
Great. And where would be the best place to look for tutorials on VisualARQ?
Well, the website there is quite interesting material available. If you go to the website Learn, you can find here, for example, a full tutorial to model the Villa Sava project and to use all the 2D drawings. You've got here some webinars. You've got here some tutorials to learn how to create Grasshopper styles for different object types. Okay. Actually, there is a webinar also that there are some examples explained in the video, and you basically will find all the learning material here. Also, these links to the VisualARQ channel in YouTube. Okay, so you can find some material there.
Thanks, Francesc. And there's a question for me. Can we see the webinar recording later? Yes, you can. I will upload it on YouTube and Vimeo. Just search for the channel Novedge, and you can watch it over and over again till the end of Google. And that's it for question. Thank you so much, Francesc. That's awesome. It's it's no surprise you got so much great feedback. I think, yeah, I think I'm gonna take the screen back just to show everybody where they can get VisualARQ and Novedge. Just search for novedge.com, and we're changing the way designers purchase 3D software because we have as many choices as you can. So you can get VisualARQ, you can get Rhino in the same time, in the same place, and we have the best price guarantee, and we have assistance if you have any trouble at all with the configuration of the product. So you can call us anytime. And as I said, I will post the video later on YouTube and Vimeo. Thanks again for watching and attending today. Thank you, Francesc. Everybody, have a great rest of the day. Bye-bye.
Bye.